Welcome YouTubers and Hubsan Zino enthusiasts, and today we're going to look at the Zino battery, and specifically the battery protection circuitry, which can fire if any one of the cells in the battery drops below a critical level, which I believe is 3.6 volts for these cells. And there's been several reports recently on the forums and on Facebook, etc., about people losing their quads, of them just falling out of the sky. And I had that happen to me about 5 or 6 weeks ago, for on one of my flights, fully charged battery, and within 3 minutes it just dropped out of the sky and the Zino powered off. I've got that battery here today, and I'm going to test it with this setup. And I suggest that if you've had your batteries for any length of time, and in fact even if you've got new batteries, you have a close look at them. I'll show you some of the things you can look at without specialised test equipment. There's no real way of testing them properly without connecting them up to some proper test equipment, but most people don't have that facility. So I'm going to show you another method here today that anybody can do, and see if their battery is likely to cut out on them. So I've got several batteries, and the one I'm going to test here, which is the one that failed on me, will show what happens when a cell in your battery pack, or more than one cell in your battery pack, starts to deteriorate. And then we'll compare it with one of my batteries, which I know are good. So without further ado, I've had to bring this indoors into the spare room here today. Not my normal workshop. It's too wet, too cold and too windy outside to do much, so please bear with me for the setup. Anyway, without further ado, let's get on and describe the test, and hopefully you'll learn something from that. If not, leave a comment below, and I'll try better the next time. Okay, so today this is our test setup, and I've had to bring it inside as it's a bit wet and windy outside to do any testing. So the first thing to note is that the Zino is strapped down onto a heavy object, so it doesn't take off, because we're going to be running this at full throttle at times to simulate a in-flight load. So first of all, I would recommend you do this perhaps outside in the clear. Make sure it's, whatever way you're doing it or wherever you're doing it, it is tied down securely and it's not going to move. And obviously remove any objects nearby that are going to foul on the props. So basically that's the setup. And we're going to power it up, and we're going to apply a in-flight load, and we're going to then monitor the battery condition. And during this test we will hopefully show up any tendency for the battery voltage to drop below the trigger voltage of the battery protection. So I'm going to show you two batteries today, one which I know is bad and one which I know is good, and we'll look at the differences and look at the indications that you may have a dodgy cell in your battery and it may be time to retire it and buy a new one, or modify it in some other means, which we might come to in another video. So then we're ready to go. I'll now get battery number 1, which has come straight off the charger, fully charged. I'll show you the voltages before we start, and then we'll see how it performs. And once we've done that, we'll move on to battery number 2, and then we'll compare the two. Okay, so this is battery number 1, and we're almost ready to go. I'm just bringing it up to full charge. We can see the cell voltage is ready now. All three are now at 4.35 volts each, and that should be finished any minute now and ready to put in the aircraft. Before we do that, we'll have a quick look at the offload voltage just before we put it in, and we'll have to look at the internal resistance measurements from this device. Okay, so that's the battery fully charged now, and I've just stopped the charger, and we'll now have a look at the cell voltages. Now before we start the charge, they were all 4.35, and you see immediately as soon as we take it off charge, two of the cells have dropped to 4.31 and the other to 4.34. If we now look at the internal resistance, Okay, we've got two cells though which have got very high internal resistance. Now this doesn't necessarily mean that they actually are. The accuracy of these tests on these charges is very random. In fact, we can very often get different values each time. But those two cells of 130 milliohms each are well beyond the normal spec that you would expect to see in a battery of this type. 34 is more typical, and even lower than that would be typical on a decent battery. But take a note of these, because these could be significant when we come to the next part of the test. Okay, here's the battery we're going to test now, and we're having a quick look with a different tester this time. We see it's got 12.9 volts. Number one cell's 4.29, 4.33 in the middle, and 4.30 at number 3. And that ties in quite closely with what we were seeing on the internal resistance readings. This time we're taking a little tiny bit of current to actually measure this, whereas the other voltmeter doesn't actually draw any current from the battery. So you can see that cell 1 is already 4.29, which is well below the 4.35 which it started at when I took it off the charger. So I suspect there's something not quite right with cell number 1. But anyway, let's get on with the test and see if this battery performs and whether the battery protection will cut in at any time during this test. Okay, so here we go. Let's load the battery and power on. I'll also start recording on my controller here. I've hooked the phone up to the controller today because it's easier to swap batteries in and out. You don't have to keep looking for the Wi-Fi if you're just doing it by the phone. Everything's connected here. And we're just waiting for the blue lights to go solid, which will indicate we've got a Wi-Fi connection. And once we do that, we are ready to go. There we go, we've got a Wi-Fi connection. We should see it. Yes, we've come up immediately. So I'm just going to go in and check that we can see we've got no GPS signal indoors here. I'm going to have to go in and change that to allow us to fly indoors. Wherever it is. No, that's okay. It's all set to go. So, first thing to note is we've got 100% battery power showing from the quad, and we're now going to start the motors and give it a bit of power and see how this alters as we go along. So I'm going to try and do this in real time, and hopefully you're going to be able to hear me over the noise of this, of these motors. If not, I'm going to have to overdub it when I put it into post-production. Here we go anyway. No, I haven't bounded yet. I'll skip that. Okay. And there we go. Now that's just now on tick over, so to speak. Battery voltage is still 100%. So let's okay, so I'm going to have to shout over the valve of this, but I see everything looks good at the moment. We're dropping to 97% here at the moment, and guess what? The quad is powered off. There we go. There's no power on this quad. Dead. You can see that I've lost all the connection to the aircraft, and that was after what? 20 seconds, I don't know. Now if I try and power the quad back on again, it won't go. So the quad will no longer power back on, and that's because the battery protection circuitry has crowbarred, as we call it, and it won't reset until I remove the battery. Let's try it one more time. No. So that fails to power on, so remove the battery. And there we go. This time it powers on. So that was a good indication that battery had actually crowbarred, and the protection circuitry within the battery had triggered. And of course, once it latches, it will not unlatch until all the current draw is removed from the source. So we just wait for it to come back up again. There we go. We're now showing 90% already, so that battery has already dropped, according to this app, by 10% of its value. And we haven't actually really done anything yet. So let's start it up again. Oh, always forget to bind. Skip. Okay, let's go. So let's give it a bit of welling. Okay, so that's probably about the normal flight power that it would be using in normal flight. And interesting to watch will be the battery voltage. So already we're showing down to 83%, 82, dropping very, very rapidly. Down to 70% already. And don't forget, this was a fully charged battery only 2 minutes ago. And now I'm just going to give it little bit of a boost there. And there, as soon as I touch the throttle, there we go. The battery is cut out again and the quad has powered itself off. So if that happens in flight, obviously it's not flying anymore and your quad is somewhere on the ground, or if you're over water, somewhere in the water, or over trees, somewhere in the trees. But it's no longer in the air. I'll do that. I'll just start it one more time and run this battery down a little bit lower. Okay, third try. This will be the last one. But already all the indications are that this is not a good battery, and this one will never be used personally by me in flight as it is currently. So the battery that we're talking about here is now 11 months old. It's maybe had 200 flights on it, 150 anyway. So it is getting on, and it's time for it to be retired. Right. Let me bind. Okay. And off we go. Final check. And this time we started the motors at 75% battery capacity. Just take it down to 60% capacity. 67 already. We're now at 60%, and I'm going to just give it a little boost of throttle, and I expect it will just cut off straight away. So drop the throttle first. That's back to idle, and we're ready at 55%. And just give it another quick boost. And there we go. It's gone. So that's it, fairly conclusive that that battery is not suitable for flight. Now we're going to do it with a second battery, see what we'll get with that. Okay, just before we move on, this is the battery that's just been removed, and we can see that it's got showing 12.1 volts, 4 volts on the first cell, 4 volts on the second, and 4 volts on the third, so they're all showing roughly the same voltage. So to me that, that battery looks perfect. Let's just have a quick look at the internal resistance again. Okay, so this is the battery plugged back up to the charger again. Notice that it's changed slightly from previously. 114, 17, that was 34 before, and 88, that's much lower. But this one's still high, that was 134 before. That's now showing 114. So the internal resistance has a lot to do with the capacity, the voltage or the charge state of the battery as it stands. Now more interesting is, I'll show you this now. I'm going to charge this battery, and we're going to then look at the cell voltages as soon as we start the charge and see what happens. Okay, so I'm going to put it on charge now. And then we're on charge. And look, immediately, this cell here, number 1 and number 3, go almost up to the full voltage, 4.3 volts, 4.3, whereas the middle one, which had the low internal resistance, is 4.14. And what that shows is that the middle cell has actually provided all the current, basically, during the flight. These other two are doing nothing much. Because of the internal resistance of these two cells, the current is very restricted. And so this is a very good indication. If it goes almost up to the full potential when we first start the charge, there's something very suspicious. 4.35 is the maximum voltage for an LIHV, and then we're ready on number 1 cell. We're up to that value, whereas the middle cell is way down low, well discharged, that cell. So that shows a complete imbalance of the cells, and of course this is what's leading to the battery failing, where those cells are dropping well below the triggered voltage long before the capacity of the battery's been used. Okay, so this is another battery. Now this is not fully charged. It's only sitting at 12.5 volts at the moment. 4.15, 4.19, 4.16, so it's slightly out of balance as well. I'll just put that on the charger and we'll have a look at the internal resistance of this one. Okay, so this is the internal resistance first of all. And those are much lower, but again the two outer cells, 1 and 3, quite high, 97 milliohms. Middle one very good, 15. That's what we'd like to see on all 3 of them. But these batteries from new have never had low internal resistances on the 2 outer cells. Let's try it again. Okay, and if we go to the meter, so that ties in with what we saw on the other little external voltmeter. Okay, let's put it in and see how this one performs. Okay, that's battery number 2, and we just have to wait for it to connect up. There we go, so this one is showing at 85% charge already, so we're not starting at 100% in this case. Right, let's go then. Bind. Okay. Escape. And we're ready to go. So, battery number 2. Same test again. Okay, so we're powered up, on idle. No change in the battery voltage as yet. So I'm going to give it a bit of welly, and I'll have to shout again over the noise of these motors. Okay, so we're down now to coming down to 80%. And that's probably more like normal idle sort of current that would be taken in flight. Probably a bit more actually. That's on idle again. So I'm just going to go through this and give it a few bursts of power to see if we can get this one to trigger the low voltage cut off. Coming down to 40% battery capacity remaining. Just had our first battery warning come up. Just put on idle for a minute. So you can see where you can hear me above the noise perhaps. We're down to 38% battery capacity on this one. And we've had that running about 3/4 power for most of the time. No indication yet as an issue with this battery pack. Coming down now to 30% will be coming up any minute now. There we go, had the 30% level indicator. It's a good way to discharge your batteries is quite quickly if you want to cycle them, but it okay, we're down to the 25% limit already, and we've got the red flashing lights indicating low voltage. And we're now at the 20% level. I'm going to give it a boost of power. 16. We're down to 15%. I'm going to stop this test now because it'll not going to do the battery any good. And there it's cut down. It's cut itself off at the low voltage limit, but the power is still on the quad. This is not a failure of the battery. This is a normal shutdown due to heavy load with the low battery. So that's quite normal. But you can see in this instance, this battery did not fail. This is a good battery, and I'll happily fly with that. Now, I wouldn't recommend you do this test very often, but what you need to do is regularly, first of all, look at the internal resistance of your battery, and look then at how it charges, which I'm not going to show you this one, and see if any of these cells pop straight back up to 4.35 volts as soon as you put them on charge. Okay, there's that battery. It's slightly warm, but nothing unusual about that. In fact, the other one was much warmer than this, and it didn't run for nearly that length of time. So let's put it on the charger. So they're all looking very equal. 3.8, 3.89, 3.87. Very good continuity across the whole pack. So again, not much change. 100 ohms, 94. I think that was 90 something the last time for the internal resistance. And more importantly, then we're going to charge it now. And there they go. Now you can see the one with the highest resistance has jumped straight up to 4.09, 404, and again this one's much lower. And that ties in again with the internal resistance, that this was still providing most of the current, whereas these ones were restricted because of the internal resistance. Okay, so that's all the testing over. And what do we make of that in conclusion? Well, first of all, to check the batteries, I suggest the following steps are taken. Firstly, we would want to regularly check the internal resistance. So firstly, when the battery is new, make a note of it, and then at regular intervals check if there are any changes in internal resistance. If you see internal resistance increasing, then that's a good sign that the battery is degraded, and you need to keep a close eye on that. And that goes alongside the voltage when you recharge the batteries. So every time you recharge the batteries, put them on charge, immediately go to the individual cell voltages. If one of those, or more than one of them, is popping up to almost the full voltage immediately, that suggests that there's something wrong with that cell. The cell shouldn't go up to full voltage for several minutes. So if it's going up there within 1 or 2 minutes up to 4.35 volts, then there's obviously an issue with that cell. So keep a very close eye on that, and again suspect that that cell is not working correctly. Another indication is poor batteries or degraded batteries is lowering of run time. So if your flight times are decreasing from 20 minutes down to 15, down to below 15, I would seriously look at your batteries. Obviously the internal resistance is reducing the usable capacity, and that goes hand in hand then with when you recharge them. So if you normally discharge your batteries to 25% and then you put them on your charger, check to see what capacity is being returned and make a note of it when they're new. If that capacity is suddenly reducing, that means they're not delivering that capacity anymore, and the only reason for that would be because of the internal resistance. And finally then, do the test that we've just done, is the finite test. Put the quad under load. Does it cut out? It only needs to cut out once, and that battery goes in the bin, or it doesn't have to put it in the bin. You can use it for something else, but I wouldn't use it in the Zino. Get yourself a new battery. Anyway, hopefully that's been useful, and I might do another shorter video on how to test them without the quad, but that means making up a little jig for the battery with a load, and you'll also need an ammeter and a voltmeter to actually measure the voltage and the current while we're running it. But that's for more advanced users, so hopefully it's been of some use. If you find it useful, watch more, because there's something else coming along shortly which you may find useful. All the best, and happy flying.